comment on the synchronization exercise. Okay, so the code for that exercise works as follows. So here are the global variables. So you have the checksum variable. This one is used by all the computations to gather a checksum. And then I have two matrices, two arrays that will contain matrices. So these arrays contains pointers to some matrices that will be initialized later on. So the code of the main program looks as follows. In here, I initialize these two arrays. So I actually put some values in here, in the mat array 1 and 2. I initialize the small arrays. So this is what I initialize. For the first one, I initialize with some random value, and in here I just put 0 everywhere. Here I display the value just to be able to check later on that the that the computation is correct. And in here I have a switch, a conditional, and this conditional is if serial equals 0, then I run in parallel, otherwise I run in sequential. So what I'm doing here, I create one thread per entry in this array. Okay, and if you look at that, this will be the parameters for the thread to decide what is the data to compute in this thread, and the function that is called in the thread is this one. Here I have the sequential part. Okay, and what I'm doing is on each matrix I apply this computation, and then I apply this one. This one we will see multiply each array by 10, and this one just do a copy. And then if I am in parallel, I have a join operation here of all the threads. Here I'm displaying the result. Okay. And here I have the checksum, so I can compare the parallel version is equal to the sequential result. Okay. Then I free the matrices, and this is done. Here is the sequential part. The sequential part, okay, I take this matrix here, and that will give me, so in the sequential part, what I do, this is mat array 1. Here I am pointing to an object in here, okay, which has been allocated in the main, and arg here is the value of this index. So I take m1, this becomes m1, and I multiply m1 by 10, and I do that for all the matrices pointed by mat array 1 by 10. Okay. In the second part of the sequential computation, what I'm doing, I have mat array 2, and again I'm pointing to a new set of arrays in here, and what I am doing here, I'm just doing a copy. Okay, sorry, copy here with M1. Okay, and what is to be noted here is that I am taking not the same index in matter array 1, but I'm taking the index plus 1 in matter array 1. So that means in here I will copy this one here. Okay, so this is 0, 1, 2, 3, 0, 1, 2, 3, and I'm taking for the matrix, the third matrix in matter array 2, I'm taking the fourth one, so element with index 3. Okay, and so that's what the computation does, and I'm computing the checksum over all values of M2s. So the checksum is computed over all values here. Okay, so it's a global variable for all the computation that happens. In parallel, I'm doing the same thing. So this is one thread. Okay, so I'm multiplying M1 by 2. Again, I have my arrays like that. 0, 1, 2, 3, 4. This is matter array 1. And in here, this is 0, 1, 2, 3, 4. And this is matter array 2. The index in here is what I got as an argument of my thread. So a thread will start to compute in here this element. Okay, multiply by 10, and then we'll compute this array here. And in here, I do the same thing, multiply by 10, that's the other thread. Okay, this is my first thread. And in here, again, I am assigning the values of M2. Okay. And again, I compute the checksum. In here, on all the values are computed by all the threads. So this is thread 1, this is thread 2. Okay, I forgot the H. So one is, and again, when I'm taking for computing M2, this one, I'm taking this element. Okay. So, yeah, this one. Okay. So, if I look at to compute this, okay, I need this result from thread 2. Meaning I need to make sure that thread 2 is done here before I can do this. Okay, and this is true here for this one, same here. So I have this constraint here that requires synchronization. Okay. I also have checksum here that I need to protect, because checksum is being updated in parallel by each thread. So I need to make sure that there is no updates that are done that are mixed between two threads. So I need to put a lock here and an unlock here. Okay, and to ensure that all the threads are done with this first part of the computation, multiplied by 10, I need to put a barrier here. So this is for the lock. Okay, so I put a mutex lock here. Of course, I have to put the unlock here, and the last part of the synchronization I need is to put the barrier between the two parts of the computation of the thread. Another way I could have achieved the same thing would have to be to have created a set of threads, a join, and created new thread to do the second part. That would have providing the same synchronization, but the cost would have been more expensive. So this barrier, to summarize, this barrier is due to the fact that I need to ensure that the other threads are done with computing M1 matrices, and this is due to the fact that this is a shared variable and I need to protect the update between all the threads. That's it for this example.